segment addition postulate. So, segment addition postulate. We'll talk about postulates later. It's going to be a key thing. I don't know if you guys heard in geometry where we do like proofs and stuff in this class. A postulate's going to be a key word that we need to keep track of. So this is the first big thing we're going to talk about. It's called the segment addition postulate. It's very, very fancy word for, let's say I have a segment that's, 5 inches. And I take a segment that's 2 inches, and I put them together, 5 inches, 2 inches. How long are they if I put them together? 7. You just did the segment addition postulate. All the segment addition postulate says, it says if B is between A and C, then AB plus BC equals AC. It means that if you have two segments, you can just add them together and it'd be the length of the two segments added together. Is that mind-blowing stuff? Makes sense, right? The hard part is we got to remember that word, the segment addition postulate. It's the reason why we can do it. So, some examples. So it says calculate the measurement of the line segments, and it says calculate the whole length, EF. I'm going to do it a little bit longer. I'm going to do this more, more in tune to the property. The property says that, well, if you have ED, how do I know that ED right now I'm talking about a length? I have ED written down, and I know for a fact I'm talking about a length. It doesn't have a line above it. If you have no line above it, no ray, no segment, no line, it automatically makes it a length. Thanks. So we're going to go ED, which we know is a length, plus the length DF. And we know when we add a segment plus a segment, it must equal the entire segment EF. Now what we do is we fill in the values that we know are the lengths. So E to D, it says it's 1.2 centimeters above it. So instead of ED, I'm going to write 1.2. Instead of DF, I'm going to put 1.9. And because they didn't expressly say what it was, I'm going to leave EF here. I know it seems pretty redundant, but now we just solve it. Now we just have to do 1.2 plus 1.9, which I'm pretty sure is 3.1 maybe? Somewhere around there. 3.1 equals EF. And we solved it. You can flip it if you want to. You can write EF equals 3.1, or we can have 3.1 equals EF. We solved what we were supposed to solve for. Our next one says find BC. Notice BC is not the entire length. BC is not the entire length. The postulate says that we could do AB plus BC equals our entire length, which is AC. There's other ways to solve this. This is just using strictly just the letters and the way they do it. You might have already seen, like in your head, I'll take that big number minus a small number, and I get there. I'm going to go ahead and fill in information I know. I know that the length A to B is 2.75. Do we know the length from B to C yet? No, so we'll leave it as BC. And the length from A to C, we know that one. That one's 6. How do I solve this one? Subtract. I'm going to talk about postulates, I'm going to talk about theorems, and I'm going to talk about terms of proving stuff. We won't have to prove anything in this first thing. It won't be on the test. But I'm going to throw a word at you. It's called the subtraction property of equality. The subtraction property of equality, you don't even need to write it down. You can just listen to me. We'll learn it later on. The subtraction property of equality lets you subtract a number from both sides. So I want us to start thinking about what allows us to do this stuff. So when you say subtract negative or add negative 2.75, we're really using a subtraction property of equality. So we subtract 2.75 from both sides. That guy stays balanced. And we're going to have BC equals, what do we end up with? 3.25. What was that? 3.25. Love it. Heard it a bunch of different places. We're supposed to solve for x on the next one. I'm going to let you try it. An addition postulate, which says, well, you could take AB, you can add BC, and that equals what? Oh, it equals the whole thing, AC. Now, AB, we don't know the actual length. It doesn't say 7. But what can I replace for length AB that will get us closer? X. Thank you for raising your hand. BC, what can I replace it with?
2x.
We got 2x. Can we replace AC with anything? We can go 2x plus 5. Because it says that A to B equals x, B to C equals 2x, and all the way from A to C equals 2x plus 5. Now I don't have any A, C's, or B's. I just have x's that we need to then solve for. I'm going to go ahead and combine on the left side. I got 3x equals 2x plus 5. How do I get the x's onto the other side? Subtract 2x from both sides, right? So we're going to go minus 2x, and we will have x equals. All right, so we come up with AC equals 15. Okay, cool. Those are our homework questions. Now we're going to talk about congruency. Congruent. Does anyone know what I mean by the word congruent? And it's okay if you don't. Just, yeah.
Same shape of line or size.
Same shape, same size. Perfect. Yeah, that's good. And it's Alejandro? Cool. All right, so congruent segments. So congruent means same size, same shape. So if I say something about congruent segments, they're already segments. They're the same shape. They're segments already. All we care about, are they the same length? So congruent segments must have the same length. They already have the same size. I mean, they're segments. They just need to have the exact same length. So we're going to talk about different ways to describe that. Do we agree that they're both the same length?
Yes.
Yes, and we'll talk about notation for that in a second. But here's one thing we can do. We can go ahead and say that segment DE, and we're going to say it's congruent to FG. Now I want to use the word congruent. They're not equal, they're congruent because it means they're the same shape and same size. It looks kind of like an equal sign, but we're going to add something to it. We're going to add a little squiggly mark on top of it. That symbol right there stands for congruent. Segment DE is congruent to segment FG. Same size, same shape. Now that you got that, I'm going to confuse you a little bit. There's another way to describe these two. I'm going to put DE equals FG. I want you to look at both ways to write that. And I want you to think about, why does one need a congruent sign and why does one need an equal sign? So I wrote the second one correct. It doesn't have a congruent symbol, it has an equal symbol. Why do I use a congruent symbol for one and I use an equal sign for the other? And maybe an easier way to put it is, why do I use an equal sign for DE and FG? Yeah. Julian?
Yes, sir.
Yeah.
Because those are numbers and not two letters.
Oh, did everyone hear that? Those are numbers and not really letters. Because DE is in place of a length. A length is going to be a number. So this is actually saying 3 equals 3. So if you're using length, you use an equal sign. If you're using the symbol, you use the congruent symbol. So congruent, if I'm talking about the segments. If I'm talking about the length, we use an equal sign.
So when it has the little line over top, it means you use a squiggle.
It means you use the squiggle, the congruent symbol. Yep. If there's no line, we need to think, when I say no line, it's actually in place of a number. And we do things with numbers like equal signs. All right, I do want to add to this some more symbology stuff. What did I use? I'm going to use a very mathematical term called use ticks. Very mathematical. We're going to use tick marks to actually show that lines are congruent rather than having to keep writing congruent statements underneath. And this will be good for pictures too. So let's say I have two line segments. I got this guy. I got this guy. I guess I could put the points on the ends. And let's say somewhere in there it says those two things are congruent, and I want to mark that on the drawing so I can visualize stuff a little better. We're just going to put one tick on each of those. And now, automatically, those two lines are congruent. Those two line segments are, in fact, congruent because I put those tick marks on there. So we could have put tick marks on D, E, and F, G as well. Now, sometimes we have really big drawings with lots of line segments on them. So what I'm going to do is I'm going to pick two more that are longer. So I'm going to draw two more that were longer than the original two. Now, my goal is all four of these are not congruent. I want these two congruent. I put tick marks on them, which says they're congruent. Now, the problem is if I put tick marks on these and they're in the same drawing, right now it looks like all four of them are congruent, but I don't want to say that. I want to say these top two are congruent, these bottom two are congruent. All you're going to do is, does anyone have a guess of what we would do? Yeah. Add another tick mark. Whoever said that, awesome job. So we'll have double tick marks. Now we go, oh, these two are congruent, those two are congruent, all four are not congruent. The top two and bottom two are, in fact, congruent. Any questions on tick marks? Very mathematical term. Use ticks. We're good? Cool. Then we're going to get to something that you're like, oh boy. Distance between 2 points. You're like, Mr. Pabian, I can just count the distance. I gotcha. On this one, I'd probably count the distance too. But you might have examples where it's like, what's the distance between this point that's 101.3 and a negative 23.4, where you don't want to have to write it out and count it. So we're going to talk about a way to get distances. Like, let's say we want the distance from J to K. It's 1, 2, 3, 4, 5. Now, I want to put a little note on top of here. See that word distance? There's something important about the word distance in the fact that it has to be positive. I'm 3 feet away from Xavier. Xavier's 3 feet away from me. I'm not going to say I'm negative 3 feet away from you. We're going to say a positive 3 feet away. So when we're talking about distances, we need to put that it needs to be positive. So I'm going to put a little star up here, and I'll say it needs to be positive. If you remember that rule, you can forget about those absolute value bars. Because all those absolute value bars are, if you find the distance between us is negative 3, you're like, it's positive 3. I'll just change it to positive. If you know distances are positive, you'll always get at least the sign in front of it correct. Now, all this formula does is you take one point and you subtract the other point. And then you take the absolute value. That's it. That's the formula. You take one point, subtract the other one away from it, and you get the absolute value. Because we're doing the absolute value, it doesn't matter which is your first and second point. You can do it in whatever order you want. So you can take the first point, subtract the second one, or you can take the second point and subtract the first one, absolute value. No matter which order you do it in, you'll come up with the same answer. Same result. So let's find the distance from J to K. I already said that it should be 1, 2, 3, 4, 5, right? So if I plug in this formula, it should be correct. So JK is going to equal the absolute value. Now, here's some advice for you. Use parentheses. I know it doesn't have it in here, but I would always use parentheses. It's something minus something. That way you don't accidentally mess up negative signs. So, does anyone want to use the negative 8 or negative 3 first? I don't care. Negative 8 or negative 3? Negative 8? Okay. So we're going to use a negative 8. If you want to, use a negative 3 first and see if you get the same answer. So I have negative 8. K will be a negative 3. Negative 8 is going to remain, but what happens when you take a negative of a negative?
Positive.
It becomes positive, so we have plus 3, which will equal the absolute value of a negative 5, which equals 5. Now, if you're someone that's like, I will just count it, you have to know this formula. All right, don't just put, I'll count it. Because we're going to have ones that are going to be like 103.3 and a negative 23.2, where people that know to subtract an absolute value are going to have no problems, and you're going to be like 1, 2, 3, 4, 5, counting. All right, now we have to do K to L. K to L, I'm going to use parentheses. Someone raise your hand and tell me what I should put in that first parenthesis. Let me put a little line here. Yeah, what do you got? Negative 3. Now that we have negative 3, what has to go in that second spot? I got one more spot. Yeah, Julian. We're going to put a 1. So let me make sure we're right. Negative 3 looks like it goes with K. 1 goes with L. Yep, I covered both those points. Now we go ahead and we do that subtraction. So negative 3 minus 1 is a negative 4, which equals a positive 4. But once again, if you know that distances have to be positive, and you come up with a negative 4, you're like, dude, I know it has to be positive 4. Like, you don't have to remember those absolute value bars. You just need to know it has to be positive. I want you to determine if JL and KM are in fact congruent, and I would like to see it in the formula. So if you're someone just counting it, I need to see the formula. So I need to use the formula to get the length of JL, and then the length of KM, and tell me if it's congruent. Make sure you understand the word congruent. And then we'll have minus, and the value of M is going to be 7. We have negative 3 minus 7, which is negative 10. Absolute value negative 10 is a positive 10. What does it mean to be congruent? Are they the same? No. So that would be not congruent. So you should have not congruent written on there. Question on distances. Got to know how to do those, okay? Know that it's subtraction, and then take the absolute value of it. All right, does anyone need that still up there? Good, awesome. All right, midpoint of a segment. What does midpoint mean to anyone? Middle. The exact middle. The exact center of that line is what we're talking about when we go to midpoint. So midpoint of a segment is a point that divides the segment into two congruent segments. Now as you write that, so we have divide, two congruent. I'm going to ask you a big question here. Can you divide a line in half?
Yes.
We can divide a segment in half. Can we divide a line in half?
No.
Is it Zahar? Did I say that wrong? Savar. I missed the letter. Sorry. You're shaking your head no. Why not?
I mean, you can divide a segment if you know the distance.
Mm-hmm.
But with a line,
I think you said it perfect. For a segment, you know distances. For a line, it goes forever in both directions. If I put a point on this line, that's not necessarily the center of the line because I don't know where it ends. It doesn't end in either direction. I can't say I have 4 feet on one side, 5 feet on the other side. I can't say this is the exact center. So a line does not have a midpoint. Only a segment does because we can measure both sides. So we have here a point that divides a segment into two congruent segments. So let's go ahead and put a point right here. Let's call it P. I guess we could call it M for midpoint. Your choice. How in the drawing do I know that's a midpoint? Like mine doesn't quite look like in the middle though, right? There's something I could do to make sure that the person reading it knows it's a midpoint. The hint is it divides it into two congruent segments. What can we do to show segments are congruent? What was that? Tick marks. Put the lines. So what I'm going to do is I'm going to put a tick mark between A and P, and I'm going to put a tick mark between P and B. Now that has to be a midpoint. Your drawing right now better have those tick marks on it. Because anytime you hear the word midpoint, tick marks need to be put on there. They'll make your life so much easier. So as soon as I say it's a midpoint, you put tick marks and say those two things are congruent. Now we can add a little wordage to this. So I can say P is the midpoint of AB, and segment AB, not line AB. And that's only true if AP is congruent to PB. So you're a midpoint only if those two things are congruent. Now we're trying to talk about like if statements. It's only congruent if something is something. P is the midpoint of AB if AP is congruent to PB. Okay, then we'll get to our next thing. You might want to have that. That
No, I'm
statement.
trying to figure out
Why what?
why PB at the end.
Oh. All right, the next thing is a bisector of a segment. When I say the word bisector, you need to think the word midpoint. Because a bisector is a line, segment, ray, or plane that intersects the segment at its midpoint. So if I ask you to do a drawing of a bisector, a segment bisector, what I would do is I'd first form a midpoint, put my tick marks on it, and then I'll draw a line through it. You have to be very, very careful with midpoints. This right here, how we could write this is we can say line MC. Now you might be like, Mr. Pabian, you said we can't do lines. I'll tell you why in a second. Line MC bisects segment AB. Anything can bisect a segment. This is not a two-way statement. What this statement is saying is this line goes through this midpoint. This statement does not say that AB cuts line MC in half. This is a one-way statement. All this says is MC bisects AB. So this says there's some line that goes through the midpoint of AB. So AB is the only one that has a midpoint. This is a tricky question. It usually shows up on an assessment where you might think it's bisecting both of them at the same time. Make sure you're clear of which one has the midpoint. It is the one being bisected has the midpoint. So if you're on an assessment and it says that MC bisects AB, put your tick marks on the AB. Don't put it on the MC. The order matters in which I say things for bisector. Yeah?
So can you like not tick a line at all?
You can't bisect. So I couldn't say it the opposite direction. I could not say segment AB bisects line MC. That wouldn't work because MC is a line.
What if you have like two lines?
Mm-hmm.
Are they both ticked, or since they go on forever, they can't be?
You can't put tick marks on it. Yep. That's why they can't have midpoints, because we can't put tick marks on those. Okay, I am going to note real quick that AB does not bisect BC. All right, so that's done with midpoints. The next thing we're going to talk about is parallel. Don't worry too much about skew. I just want to show you it. Our big word today is parallel. Parallel are coplanar lines that do not intersect. You barely have to worry about the word coplanar. You're just looking for two lines that go the same direction. These two are parallel. These two are parallel. These are parallel. These are parallel. These are parallel. These are not parallel. Do these two lines intersect?
No.
No. Are they going the same direction?
No.
No. These are what you call skew lines. These are called skew lines. These are lines that do not intersect but aren't parallel. Parallel have to go the same direction. Both of them can go down and up. Both of them can be angled. Both of them can be like this. As soon as one's going a different direction, it turns into the word skew. These are skew lines. But your big word is parallel today. Those are coplanar lines that do not intersect. So you could see M and N both go the same direction. As long as they're going the same direction, they're parallel and they don't intersect, obviously. I do want to note something about segments, rays, and the like. I put rays and segments can be parallel. But they'll only be parallel if the lines are also parallel. I'll talk about what I mean by in a second. We're just going to write it down. So rays and segments can be parallel as long as the lines, when I'm talking about the lines containing the ray and segment, are also parallel. So rays and segments can be parallel as long as the lines are parallel as well. I'm going to come back to this slide in a second in case you're not done writing. But here's my example of this. I have this segment. I have this segment here. If I was to turn those two segments into lines, would they be parallel? If I turn these two segments into lines, would they be parallel? Yes, so the segments are parallel. Counter to that is, I'm going to erase this one. I'm going to ask a misleading question. Do those segments intersect? Do the segments intersect? No. The segments themselves do not intersect. If I turn them into lines, would they intersect?
Yes.
So they're not parallel. The segments aren't parallel, nor the lines. Only if you could turn it to a line and it stays parallel, are they parallel. All right, questions on parallel or skew? All right, the last big concept today is perpendicular. Does anyone remember the term perpendicular? Heard of it? Yeah.
They intersect and form a right angle.
They intersect and form a right angle or a 90-degree angle. So perpendicular is 90 degrees. 90 degrees, baby, or a right angle. So there are two lines that intersect to form a right or a 90-degree angle. So here's an example of that. Now, here's the big thing we're going to learn today along with this. There's a symbol for 90 degrees. Do you remember that? Yep. Perfect. Yep. A little square. So if I want to say that this is 90 degrees, I'm just going to put a little square right there, and that makes that 90 degrees. And actually, as soon as that's 90 degrees, all four of them are 90 degrees. So it doesn't matter which one you put the 90-degree symbol on. All right, I'm going to add one more thing to this. I'm going to draw a very particular picture. I don't want lines. I'm sorry for anyone that's writing in pen. You should be using pencil anyway. I want this one to be a segment. I'm going to put tick marks on there. If this line cuts this segment in half, what is this line called? Not skew. Look back. A bisector. This has an even more definite term. This is going to be called a perpendicular bisector because it's got two big things happening. It forms a 90 degree and it bisects. So this is known as a perpendicular.
So the line is always the bisector, not the...
And maybe I'm doing it a disservice. This could be a segment as well. So this could be a segment. It could be, that would make it a perpendicular bisector. So it could be a segment. It could be a ray. It could be any shape. The only thing is this has to be a segment. The thing being cut in half has to be a segment. Were you asking the question?
So
So how do you know which one's the bisector? The bisector is the one that's not this segment?
It will say, yes. So the bisector is the thing cutting it in half. It will be the one that usually comes first. So it'll say like line bisects this segment, or this segment bisects this segment. It's the second one being cut in half. Yeah. Yeah. We got like 6 minutes. Any questions on anything we just covered? Okay.